This is Ray's Magnetic Surfer number 2. As you see, as I pass the gate, it has enough push to fire the little motor as a generator and the LED. What I'm working toward is an over unity effect. I'm going to be testing this half of the cycle with this half of the cycle. This half of the cycle is called the output. This half cycle is called the input. If I have, say, a penny's worth of effort to bring it into the firing point, maybe I'll get a nickel out, I call that over unity results. Less power in and you get a larger result going out. And as you see, we'll talk about this motor. There's from All Electronics. Some of the problems I've had in the past was working with something that would fire and not have problems. I'm going to demonstrate this. These are 1/2 by 1 inch by 2 inch ceramic magnets. And as you see, if there's an output. Okay. So this is what I'm working with. You can use 2 magnets. This is ceramic. They work really nice. If you get them too close, then you see we start having that back push. So basically, if you get too close, you're going to have an undertow that pulls back, and also it repels or resists the input. If you get the spacing just right, then this is reduced down to where it's not too much of a problem, and you have a nice push also. So you can just use your magnets. I went ahead and tried to bring in more of a protection. I put iron plates here, and so this is the problem I've been having. So I want to get rid of that input resistance and output pullback. And this is how it works. You have your magnetic wave, and with the other, what I just explained there, if you get too close, then you have a pullback, that wave, and also you have that push resistance. So if I brought it back far enough, that reduces that. Or you can work with your metal here. It allows you closer gaps. So here we go. This is your resistance in. You can see where it's attenuated now, and your pullback is also attenuated. So what we're working for is trying to get this magnetic surf area. Okay. So I'll show you how the plating works. If you have I have a magnet, a couple of these ceramic magnets here, and if I put the face of the magnet onto the metal, of course very highly magnetic, but what happens is that as you turn the magnets so that the edges are there, this is a north-south, north-south, well that effectively cancels that out, somewhat short circuits it, and all these forces that are looping around there trying to do inputs and output resistances, they're just sucked into this metal plate, and now we have just almost neutral, very, very little, not enough to hold it. So that's what this back plate is doing here. This neutralizes any of this wave that was coming in trying to pull that undertow of the forces. So you can see how it works very nicely. Nothing pulling back as I push it in there. See, nothing undertow like we saw the example earlier. And all we have is a nice little push there. No lockup. Sometimes it'll lock up right there, have problems. This one doesn't have that. Now, normally you'd think, boy, that's going to fly out the other way. But because of the metal plating, okay, real nice. Sometimes you have a little bit here. You do have input and output resistances, but the gearing in there gives a little bit of resistance and keeps that from flying around so much. So there is just a little bit back in there, but it's so far away from everything that your input is very, very much less than your output. So that's the idea behind it. You're neutralizing plates. They protect from the undertow, from the, I call it the output resistance, and this is your input resistance. And that wave that normally comes against it, it's kind of smoothed out and leveled out. So, okay, that's how it works. Earlier times, I would have problems with, I could get it to go in a straight line pretty well, but as soon as I started coming around, it was a problem. So here's your sizes of the one. You can use either one or two. One is just not enough to light the light very much. See, get in there. Yeah. Still no input resistance, which we were looking for over unity results. But it's just not enough power to light that up. So I thought, well, I just put a bunch around there. But as soon as you get these angles working against each other, it just stops it. So you have to have this, if you had like a long bar and you had several layers of these, it'd probably have a lot better thing going on. But for right now, what I'm just showing that this is a nice setup. I have had problems in past for things going around in a circle because all the stray magnetics, but because I have this nice shielding, everything's blocked in here, that it seems like it works even for your rotary pretty well. There's a little bit in there, huh? Okay. I shifted that around. A bit better. There you go. So that's your sizes. And this shows you your paired results. You know, between 60 and 90 degrees, you can work with that. And you can see they do have a lot more power. And no undertow to bring it back. See, it's not pulling it back. So just as that example again, I'll get my magnets. It pulls back and then it pushes away the other side. So that's the value of this. Now if you bring this magnet back, then that will attenuate just naturally your input output. So this would be your poor man's way of doing it. But it's a little bit harder to, there it fired, but there's a little bit of pullback, you can see that. Just a little bit of pullback. And probably a little bit of push there too. Not too bad, yeah, there's a little bit of push. So that's the value of the makeup of your iron bars and so forth. It gets rid of that, but for just your own experimentation, if you don't have plates, I would use your ceramic magnets and hold them back about 4 or 5 inches, and you'll get the same effect, but just not as strong. So this is the value of this setup here that I have with the plates. So this is called your magnetic Surfriders. They actually work on that wave, that part of the wave that the undertow and the input resistance of the wave is very much attenuated. So you have this coming through here. And you can see what I did here. These are from a hacksaw blade. This is a small one, and it just pulls off. That also is the same effect. You're canceling that and making a neutral zone there, so this south isn't interacting with all these other forces and negatively. And this is just a larger hacksaw blade, and it's stuck on the other side. You can see what happens here. See, the power factor is down quite a bit, but this is nice here. It doesn't have much. Now if we got closer, let's see what happens. This is kind of, I didn't do this earlier, so seeing what happens here. Has some power to it, huh? Just a little bit back in there, but this is so far away that's a very weak interaction compared to this force in there. So anyhow, this is the way I constructed it, and so I hope you enjoy this. Take your time, and this is just a little LED. You see that for over unity results, the input is much less than the output. So let's say we're putting a penny in, and maybe we're getting a nickel or dime out. So anyhow, this is how far I've been on my magnetic Surfriders. Thank you for watching.